Hello everyone. So this is the second numerical from force vibration. So in this question, there is a beam. On that beam, there is an oscillator. It will be vibrating at a speed of 600 rpm, and the mass of the mass of the machine or the oscillator is equal to 5000 Newton. And when it is placed on that beam, it produces a statical deflection of this amount. Okay, and you have to find the magnification factor of force vibration. So we know the magnification factor equation is equal to how much? That is mu is equal to 1 by 1 minus eta square plus 2 eta xi whole square. So this is the magnification factor, as you all know. So if you don't know, you should just go through the last lectures. So we have to find this. Okay, so here the eta you should know and xi you should know. Eta is equal to, in the last lecture we have solved this eta. So eta is equal to how much? Eta is equal to omega by p, and xi is equal to n by p. Okay, now n is equal to c by 2m. Okay, so we have to find this omega p c m p. Okay, so here omega is equal to how much? So the frequency of forcing vibration, this is equal to the frequency of forcing vibration. So you can write here the frequency of forcing vibration is equal to omega, that is equal to how much? 600 rpm. Okay, so 600 rpm. So we have to convert this in radian per second. So revolution per minute. So in one revolution the machine rotates, or the rotational displacement is equal to 2 pi, and so 2 pi radian. So 600 rpm, that means 600 revolution is occurring per minute. So we have to find, or we have to represent this in radian per second. So 600 into 2 pi, because in one revolution 2 pi, and per minute, so you have to divide by 60 second. So it is radian per second. So it will be 20 pi radian per second. And the mass of the body, so here the weight of the oscillator is given, so that is 5000 Newton. So we can easily find the mass of the vibrating body. So the mass of the vibrating body is equal to 5000 by 9.8 kg. So it will be you can find this. Okay, now this static deflection is given here, and we have to find the omega p c. Okay, so in, if you want to find p, that p is equal to root under k by m. Okay, so here we need k, and so k can be found like this. So k is equal to f naught by delta st. Okay, so f naught is equal to how much? So this force of the oscillator is equal to 5000 by this sigma st. So sigma st is equal to 0.025. It is in centimeters, so you have to convert it into meter. So this will be the stiffness 20 into 10 to the power 6 Newton per meter. Okay. So now uh, we have found this K. So let us so P is equal to root under K by M. So K is known, M is also known, so this is the M. Okay, so we can find this P, and this on omega is found. Okay, now we have to find this N, and so we have to find this N. So now this N is equal to C by 2M. So if you can find this C, then you can find this N, and we can find this Xi. So here mass is known. So how can you find this C? So for that you have to concentrate on these three lines. That is, assume that damping is equivalent to a force acting at the middle of the beam proportional to the velocity. Okay, so it is equivalent to a force which is acting in the middle of the beam proportional to the velocity and equal to the 500 Newton at a velocity of 2.5 centimeter per second. So just let us write these lines in numerical form. So as we all know, so damping force, so you can write it Fd is equal to or is proportional to the velocity, or the damping force is equal to C into x dot. So that C is damping force by velocity. So here in these three lines the force is given and the velocity is given, so we can easily find the C. So damping constant C is equal to Fd by x dot. Okay, so so C is equal to 500 by x dot. So this x dot is the velocity, it is in a centimeter per second, so we have to convert it into meter per second. So 2.5 by 100 meter per second हुआ. So then it is Newton. Tick. So so it will be you can use this C in this equation to find out the N. So N is equal to C by 2M. So C, if you put the value of C and M, because you know this is the M, so you can easily find out this N. So N will be 19.6, you can find. Okay, now this Xi, so now we can find this eta and Xi. So eta is equal to omega by P, so omega is equal to 20 pi, okay, by P. P is how much? So we have not found the P, no? So P, so before this part find this P, so root under K by M. Okay, so P will be your 198 radian per second. Okay, I hope you can find this. Okay, so let us go to the next page. Okay, so this eta, so what we have found, we have found this, oh, we have not found this eta, na? So eta will be 198. Okay, so it will be 0.32. Okay, let us now move to the next page. So this Xi will be N by P. So N is equal to how much? this will be 19.6 by 197 or 198, so it will be 0.099. so the magnification factor, so the uh, magnification factor is equal to 1 by minus eta square whole square plus 2 eta I. Okay, so 1 by this 1 minus 0.32 square whole square plus 2 into 0.32 into 0.99 square. So okay, so this will be 1.111. so this is the answer. So for this type of numerical you should always remember these equations.